Yeah. I'll put my stream on the side. Let's see. I'll put my stream on the side. Let's see. 15 key steps. Will be this time. To reverse it, we'll get 765, 3 to 1. What? One, one, two, three, four, five, and six. Fifty is equal to 1, 2, 3, 7, 8, 300, 700, and 1, 2, 3, 4, 5, 6, 7. It'll basically be the same original array. So we can do something like is equal to num dot size, k is equal to k mod, sorry, k will be equal to k mod m because it might overlap, right? And then you have to basically 1, 2, and 3. So that is k. No, so it'll be like k from the back. This index is n minus k. 7, 1, 2, 3, 4, 5, 6, 7, 7 minus 3, 4. It's a void function. You have to do it in many cells. Do it in place, I might lose like these values, right? That's one thing. If I do it, if I add these here, I might lose them. What it's gonna do? No. Yeah. I think that's a better way of doing it. Here, okay, we're doing this, and then after that, reversing this. Oh, okay, makes sense. And now, so after reversing, you have to reverse this part, which is 0, like beginning till 0, 1, 2. Basically nums plus k. Reverse once again. Nums and plus k, because you need to have, like, if k is 3, right? And so it'll be 0 plus 3, and the ending always should be like one after the other. Like basically the ending iterator should be after the last index. And then we reverse nums begin plus k plus 1, I think. 0, 1, 2, 3. No, okay. Wait. No, no, that's I think k. And then here. Hmm, something's wrong. Wait. Why am I getting a runtime error here? Oh, okay, sure. It's none begin. Whatever, like, I don't know. Kind of a typical question. There's no pattern involved here. So the time complexity would be you're reversing, right? So that takes O of n, and then for example, you're reversing n, and then you're reversing k, and then you're reversing n minus k. Worst case, it's O of n. Yeah, so you can do it O1 extra space. This is the O1 extra space solution. Yeah. Yeah. No, but I don't know. Kind of a typical question. There's no pattern involved here. So the time complexity would be you reverse. I, I thought this was like kind of a DP question, but maybe wrong. Wait, let me see. Length of the longest consecutive element sequence. I think I've done this way back, I guess. Not sure. Okay. So, it's sorted, right? If we sort it, then we'll get 1, 2, 3, 400, 200. Oh shit, but it says O n time. Sorting it will be O n log n. Mm, mm, mm. Okay, probably can I use a set, kind of an hash set or something? So but it's all unique. Oh, okay, it's not unique. 0 and 4. For example, 4, right? When I get 4, I'll check if I have 4 plus 1, I have 4 minus 1. So there's nothing there. 1, nothing there. 3 plus 1, 3 plus 1, 4 is there. So we do plus 2, then 2. Yeah, I'm thinking hash table though. Hmm. 3 plus 1, 3 plus 1, 4 is there. You might add the same character once, like twice, right? For example, you added here plus 2. For example, here you add 4, 1, nothing happens, then 3 you add. Then you say, okay, 4 is there, so you add 3 uh, as well as 4 to your set. Create another set here. For example, let's just say this is called S. And then after that, when you go to 2, you'll do, okay, 1 and 3. Um, you see that 1 is there, so you add 1 and 2. You also add 2 and 3. Um, but since it's already there, this is preserved. So I need one visited set and one some answer vector set. It should work, right? So we have two numbers, IT minus 1, IT plus 1. If this visited set has n1, then we add. So basically, what we're doing is, for example, in this case, 3 plus 1, 4 was there. So we will add 3 and 4 both. So we'll add 3, answer, insert, IP, answer, insert, n1, and then we'll do the same here for n2. Same thing. The answer will be our answer 5. But this, no, but we have to find the longest sequence, right? This can happen, for example, there will be like 7, 8, 9, and then if I have like 1 and 2, 3, something like that, then you might get, uh, yeah, how would we find the longest? How would you find the longest concept there is? This won't give that, right? Hmm. Bro, I just use sorting here. How can I do that? Hmm. I think I need to see the solution for ON, I guess, because everything I'm seeing is O n log n. My oldest submitted code also has like sorting done here. I don't know why I did that though. I think you should watch this video.
Problem, and it's actually been asked by a lot of companies, including Google.
Bro, I just use sorting here.
Find the longest consecutive sequence. In this case, the longest consecutive sequence is 1, 2, 3, 4, right? It doesn't matter what order the numbers appear in the input array, we just want to know the longest consecutive sequence that we can make from the input array. Now, the most obvious way to solve this problem is just by sorting, right? So if you look at the sorted array over here, we have obviously
Oh,
one.
this video is like 5 years ago. At that time, this was hard. Yeah.
Consecutive sequence of length 4, right? 1, 2, 3, 4. They're all consecutive numbers. We also have another one that's length 1, just 100. And we have the last one that's also length 1, just 200, right? Now better. So this is Leetcode hard. Obviously the solution wouldn't be this simple, so we can do better. But how do we get there? Now the first thing to do is try to visualize the problem in a way that it makes the problem really easy to understand. So I visualize the problem by drawing out an imaginary number line, right? So we can kind of see what the sequences actually look like. This makes it a lot easier to recognize the patterns. So we know we have one sequence that starts at 1, 2, 3, and 4. We have another sequence that comes after it with just one number, 100. We have the last sequence with also only one number, 200. So just by looking at it, we can tell we have 3 distinct sequences, right? That's something to recognize.
Bro, like you can see, like this is quite an early video of Leetcode's. You can see he doesn't have the enthusiasm. That time he was just learning himself.
Now, by visualizing it, we can kind of try to approach how would a human solve it? Well, the easiest way is just look at each of the sequences, right, and count how long they are. So let's look at the first sequence, right? We have 1, 2, 3, and 4. So this sequence has 4 numbers in it. We have the second sequence, just 100, so it only has one number in it. So it's a sequence of length 1. The last one is also a sequence of length 1. Now this is so easy to solve when you visualize it and try to approach it how a human would, but can we actually convert this into code somehow? The answer is yes. So the most important thing to notice is that we have 3 sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? The thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. The start value solution wouldn't be this simple, so we can do. In this case, the start value for the first range, or the first sequence, has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious. Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning if we wanted to check if 1 had a left neighbor, we would check, does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we'd check, does the array contain 99? The easiest way to do this and the most efficient way to do it is by taking our initial array and converting it into a set. So now to find the start ranges, let's start iterating through our array. So we get to the first element, 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it, so this is the first. So this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to get the length of this sequence, we want to count how many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array, so let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number, 4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence, and we can check this using our set. We would check that it does have a left neighbor, right? 3. So it's not the start of a sequence. We're not going to make a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is, and we know that 199 does not exist in our set. So let's make this sequence. Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set, so let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number, 3, exists in our set. Yes, it does. So let's make it even longer. Now does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor too. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire array and we had to expand each range, we know that we're only going to visit each number at most twice, so our solution is very efficient.
Let me try to code this up. So I was almost correct, I guess. I was using a set, but Should be like something like that. Okay, it's better to do something else. Like, like really, um, really this one. So we'll have like so our current length will be 1. We already have one length here. Let me check. Okay, is 2 present? If 2 will be present, then we'll do current plus plus, next plus plus, right? But before that, we need to initialize the set with all the values in this. By the way, for example, 50001. Okay, then it will not be right. Okay, we don't even need to consider equals. Right? Yeah, yeah. Set will work our case. Current is our length, so 1. And then we do, then we find next we'll do current plus plus R2, and then again we'll do this math current. Yep. Mm, What I'm thinking is like, do we, can we avoid like, for example, here I've already visited 3, right? I've added in my, Maximum we are visiting every element twice, so it's proportional to O(n). What the hell? Mm. Why am I getting a time limit exceeded for this solution? Oh, damn. Okay, wait. Okay. Mm-hmm. Clearly. Yeah. Wait, what's the time complexity? Well, let's see. It's O(n), right? Why is it taking so long to run then? So yeah, essentially I optimized it so basically I won't go over like elements twice.
Consecutive minus 1 does not exist in our checking if it exists in our num set. If it does, then we can keep expanding the length. So initially, I'm going to check n plus length because that's going to check the current number. Initially length is 0, so we're just checking the current number. As the length grows, we'll check more consecutive numbers. At the end, we could have potentially found the longest sequence. So we want to potentially update our longest by just taking the max of the current length we just computed as well as what the longest originally was. And it's really that simple. So now all we have left to do is just return what the longest the longest sequence was that we just computed. So we did this in such a small amount of code. Now let's just
Let me just verify this using the data thing. So I've created a chart in which basically it tells me the time complexity and everything of my code, and so and also like generates follow-ups so that I can, be prepared. What do you mean, like, don't accept it though? It's the same code, right? What I wrote. Then why is it? What's the difference? No, bro. Oh, I think I'm gonna get it clearly. So, like the code that DeepSeek suggested is giving me TLA, and my code is correct. So I'm gonna go with mine. So yeah, whatever. Why don't we start sequence of numbers that don't have numbers, optimization? Mm, yeah, actually, this is a good optimization. This optimization I did because, like, for example, we have like one, two, three. I've already like like one, two, three in this order itself. So I've already processed one, right? So I know this goes to this, goes to this. So we've already processed it. So me again checking here will be like an overdoing, right? So I know that this number is already part of like some sequence, right? And already calculated that. So there's no point in checking it. So I just add it to another set called cur, in which I'm adding it, and then I'm checking it again. Yeah, so this is a good way of, for example, you can just ask DeepSeek or ChatGPT, just give key optimizations on your code, and then um, probably it can, solidify your understanding. I'm just gonna go and read through this. Bro, what the hell are they asking? Stream processing, database approach, Bloom filters. Yeah, I don't think this will be asked. Yeah, union find can be asked. Hmm. Basically, num plus one union sets. So you can aggregate all the components based on num plus one number. So I was also doing that, but yeah, that was not the correct answer because I needed to get the biggest, the largest size. Mhm. I'm gonna end this stream in 15 minutes. Yeah, I don't feel like coding today. Some other work also.
Longest sequence. So we want to potentially update our longest by just taking
Another one. Yeah, let's solve one easy and then go. We're gonna probably write this. Yeah, it's actually a good um solution to keep in mind. There's no proper um pattern that we used here, right? Can we modify the values here? I always have this question, like, can we just modify the values and do that? We should have done it using that only. Okay, wait. There's something else. Let me just see. Given the head group or no, can this be done?